Let's do a lightning round of all of our classrooms again. Let's do one question from each of our classrooms. So go ahead and get yourselves ready. We're going to come to you quick, loud and clear. How about Georgia, St. Luke's School? We're ready.
How much water does snow produce annually?
Oof. How much water does snow produce annually? It's a very good question, but a difficult question to actually measure in very quantitative terms. But in Colorado, for example, the majority of our water that comes from the air comes as snow in the wintertime. And that snow gradually melts to provide us with our water supply. And if you wanted to get numbers, you could look, for example, at the flow rates of the river systems that are leaving Colorado, and the majority of that water would have come as snow. So if you want to get some numbers, you could actually go to the computer, and you guys could go to the internet, and you could find out how much, for example, how much water is leaving Colorado in those river systems, and you could make the assumption that somewhere between 60–70% of that water came as snow and is now leaving Colorado as water.
Fascinating. Mount Tabor Elementary, are you all ready?
Go ahead.
We can see you and we're ready to hear you.
Mount Tabor, I'm not sure that your mic is on because we saw you talking, but we couldn't hear what you had to say. So can you repeat your question?
Is there more fresh water in the world above ground or underground?
Okay, so the question was, is there more fresh water in the world above ground or underground? And the answer is most of it's actually underground. So the fresh water of the world is a very small proportion. Most of the water is salty water. And our water supplies that we use are the waters that we can find on the surface. And it's only a small proportion. If you think of all the world's water, if you put it all in a gallon jug, just to think about it in that way, there's only 3 little Dixie cups that are fresh. Most of the water is salty. And of the 3 Dixie cups, actually 2 of them are frozen. So 2 are filled with ice cubes. There's only 1 Dixie cup that is the fresh water that is liquid on the Earth's surface. And the vast majority of that fresh water that is liquid on the Earth's surface is actually in the Earth as groundwater. And only a small proportion of that is available on the surface. And if you think about it, it's only the size of an M&M is the surface water. So we're relying on that little tiny bit of fresh water that's on the surface for the vast majority of our drinking water.
Great. So we'll take a quick one from online. So we've got our friends in Alaska. Students are wondering that since we have so much water in Alaska, especially Kodiak, is there any way we could share it with places that don't have enough water?
You know, they've thought about that. One of the hard things about moving water from Alaska is that it's a long ways away, and water is really heavy, and it's kind of expensive to move. We do move water long distances, but we haven't moved it quite as far as you guys are talking about yet right now. But there are certainly pipelines in Colorado that move water through a series of pipelines and ditches hundreds of miles. There are also those similar sort of pipelines and ditches and other infrastructure in California that moves water hundreds of miles. We haven't gotten to the point of moving the water thousands of miles from Alaska down here, though. But thank you for thinking it up.
Great. Let's take one more from online before we go to classrooms. So how about from Emily in Montana? Does a watershed ever end before it goes into the ocean?
Ultimately, no. I mean, you can talk about smaller watersheds that end at a point that might be of interest to you for one reason or another within that watershed. It may be the water that drains into a lake. It may be the watershed above the intake that your town uses for water. But that water does continue to flow downstream, and it is in a watershed until it gets to an ocean.
Great. Let's go to a classroom. How about Toke School? We're doing the lightning round. So one question. We'd love to get that from you, and then we'll go to North Star. Right now, Toke.
How many animals die from polluted water?
How many animals die from polluted water?
Goodness me, how many animals die from polluted water? Well, I think you might, if you think about it on a worldwide basis, I'm sorry to tell you that people die from polluted water. And so one of the things that we're concerned about as scientists studying water and water resources is how to keep enough water clean on a worldwide basis so that less people get sick from it. And I think in the natural world, animals are pretty resilient for the most part. And there are cases where if we pollute a river, the fish will die. There are cases where if the water gets too polluted, some of the animals that drink it will die. But we've been making big efforts to clean up those river systems on a worldwide basis. And I think a lot of people are spending time now looking at how to keep the water clean for people.
Great. Lightning round style North Star. We are ready for you. Yes, indeed. Yay.
How does water get to the ocean after we use it?
Well, water flows downhill. So after you use it, it depends on how you're using it. But typically in a city, what happens with the water is that it will flow through pipes out of your house, out of your school, and will go to a water treatment facility where they'll clean up the water. And then it typically goes back into a river, and that river then continues downstream. Now, if you think about really big river basins like the size of the Mississippi, if you're at the top of the watershed, the water flows out of your house, goes to a water treatment plant, and back into the stream. But if you're farther down, you may be using that water again. And so the water can get used many, many times. It's taken out of the stream, it runs back into the stream, and eventually we continue to use it until it gets to the ocean.
It's like the water cycle is the original recycling. That's pretty cool. Thanks for explaining it in that way. Got a question online here, and it is how it's coming from Marianne in Virginia. How are people going to share a dwindling supply of water?
Well, Marianne, that's of course a super question, and it's a worldwide question. And one of the themes that we'll talk about here is we've talked about caring for water, and we talk about sharing water. And we do share water worldwide. And I've traveled a lot around the world, and I work in Africa, I've worked in Asia a lot, I've worked in the Middle East. And wherever I go, people are sharing water. Everybody needs water. Everybody needs clean, fresh water. And water is a resource that is finite, is limited, needs to be cared for, and it needs to be shared. And we have a wide variety of organizations. We have rules, we have systems that encourage us to share water equitably. So that is a challenge, though, in many parts of the world. And it continues to be a challenge, and you'll be reading about it in the news.
So we have one more from online. We'll take fracking, the extraction of coal and things from in the ground. How does that affect our fresh water?
It kind of depends. And some of it depends on the relationship of where the hydrocarbons are to where the water sources are. In some places, they're fairly close. The strata that bear the water and the strata that bear the hydrocarbons are pretty close, and you have to be very careful with the fracking so as not to interfere with those groundwater supplies. In other places, such as in eastern Colorado, where on the Pawnee National Grassland, one of the areas where I work, the hydrocarbons are at thousands of feet of depth, and the water is usually at less than 1,000 feet of depth. So there's 6,000 feet of rock separating the fracked hydrocarbons from the water. So there's quite a bit of protection left there.